Hi, this is my demonstration for part B of the sensors module assessment calibration. In this video I'll show the use of the MPU 6050 to track the yaw angle of my flying fish and how I've implemented the gyro bias calibration method to reduce the drift. The sensor's mounted on top of the fish with the Z axis pointing upward out of the fish. Yaw is rotation around the vertical axis, which matches the way this fish rotates on the support pole when it's all up and running. Below the fish we have printed reference angles that shows a visual comparison of the calculated yaw angle. So when the Arduino powers up, it performs a calibration by reading 500 samples from the Z-axis gyroscope while the fish is stationary. It calculates the average gyro bias, which is then removed from all subsequent readings. So when we fire this up, it'll be quick. So it's calibrating and then taking readings. So just recalibrate it so it's at the 0 position there. So calibrating. Alright, and then as I rotate the fish to 45 degrees, it's just paused there, but it nearly got there. Seems to keep freezing every now and again. As I reset, slowly rotate to 90 degrees. Now it's frozen again. That's it at 90 degrees there, which it just moved as I had it there. So trying to get it all working at once was a little bit tricky for the video, but it more or less accurately represents the angular movement. So then the last thing that we'll talk about is thanks to the bias calibration, the yaw angle actually remains stable even when the fish isn't moving, which previously I was playing around with it, that wasn't the case. So there was about a 1 degree per second amount of drift. So I'll just restart that and show that it holds pretty stable. Staying pretty still around there and before it freezes again. So to summarise, this demonstrated the calculation of the yaw angle using the calibrated sensor. I applied a 500 sample bias correction, which significantly reduced the drift and made the yaw measurement much more reliable. Thank you.